Now this question says that the diagram shows a circle with center O. A, B, C, and D are points on the circumference of the circle. Angle ABC is 128 degrees. That's this one. Work out the size of the angle marked X. Now this will take us to a topic I titled circle theorems. Okay? Circle theorems. Now what are circle theorems? They are rules that we've observed that angles in a circle actually obey. Okay? Now one of them is that the first one, angles on the same arc are equal, or angles subtended by the same arc are equal. For example, let's say this is a circle. Remember from our circle video, this is an arc that's from a part of the circumference, or a portion of the circumference. Okay, now if this arc now subtends this angle at this circumference, at this point of the circumference, and this same arc again subtends this angle at this point of the circumference, let's call this theta and theta 1. This theta and theta 1 equal to theta 1. This theta and theta 1 will be equal because they are subtended by the same arc on the circumference. That's what the rule is saying, that angles subtended by the same arc on the circumference are equal. Okay, now another rule is that angles subtended by diameter at the circumference equal to 90 degrees. Now if we have a circle too like this, we're just trying to say that the angle that this diameter will make at the circumference is always, or will always be, 90 degrees. Okay, no matter what. Once is the diameter that is making that angle on the circumference. Okay, once is that diameter that is subtending on the circumference, it must always be 90 degrees. Okay, now the third one says that the tangent to a circle forms a right angle with the radius of the circle at the point of the tangent. Now before we go ahead, we'll ask ourselves, what's a tangent? First of all, a tangent is a line that, let me show you. Now this is a tangent. It's not completely accurate because this is a freehand sketch. Now a tangent is a line that just touches a circle briefly and continues going its way. It doesn't cross the circle, it just touches it briefly as a point. You can see that this thing actually rubbed the body of the circle, which is not how it's supposed to be. You're supposed to touch it at a point and just keep going. Okay, so at that point of contact, they're now saying that the radius at that point of contact, okay, to the tangent is, that's the angle between the radius and the tangent at that point of contact is always 90 degrees. You could even see it from here. If this is the radius at the point of contact here, and the tangent is here, and this is the point of contact, it will always be 90 degrees no matter what. Now another one is saying that if there are two tangents, let me show you another circle. If we have two tangents here, another tangent here, actually this is not supposed to cross the circle, it's supposed to go that way, but it's freehand sketch. If this is tangent 1 and this is tangent 2, they are trying to say that two tangents, okay, of a circle, okay, they have equal length from the point of contact to the circle, and the point of contact to the circle to the point at which they intersect. That's this, from the length from here to here should be the same from here as the length from here to here. Okay, that's the length of two tangents to a circle from the point of contact on the circle to the point of intersection is always the same. That's what they are trying to say there. Okay, now another rule is that the angle subtended by an arc at the center of a circle is equal to 2 times the angle it will subtend at the circumference. For example, let's say this arc is subtending this angle at the center. Let's say this is the center. Okay, now we're saying that if this same arc subtends an angle at the circumference, okay, that this angle now will be theta, this one will be 2 theta, that this one will always be double of what this one is. Okay, once it's the same arc that subtends it. Okay, once it's the same arc that subtends it, that this arc will subtend 2 times of what it will subtend 2 times at the center than what it subtend on the circumference. Okay, now using that to solve this question, we were asked to find this angle theta. Okay, now let's take this arc, let's say that it subtends this angle, this arc AC. Okay, let's say that, or ABC, no, or ADC. Okay, let's say that it subtends 128 here. That means the angle that this same arc will subtend on this center is going to be double of what it has here. Okay, now checking it, you're going to have 2 times 128, that would be 256. And you notice something, that this arc now subtends this angle at the circumference. Now this same arc now, that's ADC, the big arc, okay, it now subtends this angle at the center. Okay, now that's why when we saw, because of the rule we had, that an arc now, the angle it subtends at the circumference is going to be half of what is going to subtend at the center. Okay, that's how we got 256. That's how we multiplied 128 by 2 and got 256. Okay, now for you to get x, what are you going to do? Now there's another rule that says that angles at a point equal to 360 degrees. Okay, so angles at every point or at the center of a circle, you could still say center of a circle is the same thing, equal to 360 degrees. So for x will now be 360 minus 256 degrees, so it's going to give you 104 degrees. So that's how you find your x. Now we've put two things in place. The first one is saying that angle ABC is equal to half of angle AOC. Okay, or half of angle AOC. Okay, Now that's this angle now. Okay, now being half of it, that means angle AOC will now be 2. Angle AOC will now be 2 times 128, which is going to be 256. Reason being, angle subtended by an arc on the circumference is always half of the angle the same arc subtends on the center. Okay, now after getting that, we now said, okay, angles at a point equal to 360. That means x plus 256 is equal to 360. Then we now found x to be 360 minus 256. That's 104, 104 degrees. So that's how we solve that one. We have another question here that says A, B, C, and D are points on the circumference of a circle. Okay, we're told that this ABD is 54 degrees and BAC is 28 degrees. We're now asked to find the size of angle ACD and give reasons for our answer. Angle ACD. Now, one of the circle theorems we had was that the angle that an arc subtends at a circumference, if that arc should also subtend another angle at the circumference, that it will always be the same. So in other words, we're now saying that this arc AD subtending this angle 54 degrees at this circumference, at this point B, this same arc now is now subtending the same angle at this point C. So this angle is equal to 54 degrees. Reason being that both of them are subtended by the same arc at the circumference. An angle subtended by the same arc at the circumference are equal. Okay, now that's it for circle theorems. They actually come the way the theorems are, so it's not up to us to actually apply each theorem that fits and then solve the question. So that's it for circle